All right. Hi, everybody. Thanks so much for coming out. Really appreciate it. My name is Cassie Zimmerman. I'm with Redis Labs. And today I'm going to be talking a little bit about scaling your applications using Redis and Redis Enterprise and Pivotal Container Service, also known as PKS. My role here at Redis Labs is to work with our ecosystem and build the technology integration with players in the Kubernetes, the Cloud Foundry space, and elsewhere. So appreciate you guys being here today. So first and foremost, who are we? Redis Labs is the home of open source Redis and also the commercial provider behind Redis Enterprise, which is a really stable, mature platform to run Redis workloads in a highly distributed manner. When I say we're the home of open source Redis, I mean that. Salvatore Sanfilippo, who's the original creator and founder of Redis, is a part of our team. We also have 100 engineers, plus 100 engineers, backing him to develop on Redis, to develop on Redis Enterprise every single day. So we are Redis by Redis. So what is Redis, for those of you guys in the audience who might not be aware? Redis is a completely in-memory database. It's a key value NoSQL store. Very popular amongst the developer community for its flexibility and ease of use. Very often used for high-speed transactions or analytical use cases where you need to reach a million plus operations per second with consistent sub-millisecond latencies. So when I say it's popular, I do mean that, and we did some digging through our friends at Docker to show exactly that. As you can see from this slide, Redis was installed in Docker containers upwards of 700 million times, and that was as of April 2018. Since then, it's reached over 900 million downloads, which is more than MongoDB, MySQL, and Cassandra combined. So as you can see, the developer community loves to run Redis in containers, and obviously when you're deploying many containers, that turns into Kubernetes, so it's equally as popular in that world as well. Just to kind of reinforce the community that we have behind Redis, a couple of more statistics, and I'll get through this really fast. In case you didn't know, it was the most loved database on Stack Overflow, which was a survey conducted of over 40,000 developers globally. It's the #1 NoSQL database on AWS in terms of usage. It's the #1 database in skill demand, and so on and so forth. Is there a reason it's not working? Maybe I just got to go back. OK, there we go. So why? Why is there such a developer community backing Redis? And it comes down to really two key components, among others, but I argue it's simplicity and its flexibility. The ease of use to even install Redis is incredibly simple, right? You install Redis, you run a single binary, you type Redis, and you're off to the races. Flexibility comes with the data structures that are fundamentally built into Redis. And this is in a developer's toolbox. So we have things like strings, bitmaps, lists, streams, sets, sorted sets, hyperlog logs. And these are basically building blocks for the developer to use and build application code on top of. So the ease here is that it allows for application development processes to be a lot cleaner, a lot smoother, and ultimately deliver more complex functionality with less code and a faster time to market. So oftentimes we see people using Redis for leaderboards, for user profile stores, for a session store, for real-time personalization, real-time advertisement places, because you can use these structures to kind of build that type of more complex use case. And to take that a step further, about 1 year ago, we introduced a concept called Redis Modules. And what this does is it really extends kind of the data structures and the use cases that Redis can support. And what this is it's an add-on that uses a Redis API, and you can implement any other data structures that you want to develop. So we have well over 100 modules to date from the developer community. In-house at Redis Labs, we focused on 5 core modules that we're going to be supporting in the enterprise product. And that's the JSON module, so you can store JSON data in Redis, the Redis search module, the Redis machine learning module, graph module, and streaming. So this is really exciting. It really does open up the range of use cases that you can support with Redis and the things that you can do as a developer with Redis. So with all of that being said, a good friend of ours at Pivotal, Josh McKenty, I think articulated this quite perfectly. He said, Redis is a natural choice anytime you're trying to make your developers happy, right? It's loved by them, it gives them the tools that they need, and it works, right? And that should be always, right? You should always be trying to make your software development team happy and building and deploying software faster. When we give a team like developers, different mental models for solving particular problems, the more tools that they have to solve each problem, you're killing their efficiency. So the beauty of Redis is that you can have one tool to really take care of 8 use cases, right? You can use it to store data, you can use it to cache data, you can use it to store JSON data, and you can use 2 other tools for the more niche use cases. So the power in it from the tool in the toolbox standpoint is really, really big. But in order to run it in production as an enterprise, you're going to need it to scale, right? You're going to need it to have automatic clustering, rebalancing, resharding, cross-data center replication. You're going to need a distributed platform running underneath it so that you can run, hundreds, thousands of applications and workloads at once. So that's where we come in as Redis Labs. Redis Enterprise is the product that we have spent the past 6 years developing, and it's a very mature and stable platform for people who are looking to run Redis open source into production and hand it off to their operations teams, and the developers want it to run the way that they expect it to, right? Highly available, scalable, not going down. They built great software, it's close to the customer, and it's just going to work. And I'll get into the architecture and the specific, features and functionality that we have in just a minute here. But first, I'm just going to kind of explain the different deployment models that we have for Redis Enterprise. We actually started as a software as a service model, so you can swipe your credit card, we'll manage your entire Redis deployment for you. That's on every public cloud imaginable, as well as private infrastructures. And that's available since mid-2013, and we have well over 8,000 enterprise customers to date. On the right is what I'm going to be focusing on today, and this is the downloadable Redis Enterprise software. You can run it wherever you want. You operate it yourself. Same exact software, you get the same functionality. It's just dependent on what you guys, however you guys want to run it. So before I get into the specifics, Redis Enterprise expands upon the core principles of Redis, which is developing software should be fun, should be easy for the developer, and it should be simple and transparent. And when we built Redis Enterprise, we built it on the exact same open source software that Redis is built upon. So it supports the same open source clients. If you're running Redis today for an application, you can implement Enterprise at the click of a button, and it's a really seamless process. So I'm going to get into just a couple of specifics around how we handle scale and how we handle high availability. So first off, Redis is fast from the get-go, right? We make it extremely fast. Our last benchmark went from 30 million operations per second to 50 million operations per second. And I believe the infrastructure on that was 40 servers or so, maybe 50 servers. So really, really a powerful technology. The problem that we see with our customers when they're deploying open source Redis in production is that it doesn't support clustering out of the box. So scaling open source Redis becomes really, really quite a burden. It gets really complicated, really complex very quickly. And our job is to solve that without it impacting performance and also adding HA on top of that. So you can see here, our Redis Enterprise deployment framework is pretty much made up of 2 components, and that's the enterprise layer on top and the open source layer on the bottom. The enterprise layer consists of a zero latency proxy, which is kind of an air traffic controller. It sees the request coming in, and it deals with sending the correct request to the correct shard underlying. The cluster manager is pretty much a DBA in a box. It's watching all of the nodes in the cluster. It's checking the health of it. It's giving you alerts if you need to scale out. If there are too many requests coming into the cluster, this is your DBA in a box. And then a REST API so that you can have a UI, you can have monitoring, you can have alerting, and you can connect it into any type of UI that you choose. In the bottom, from the open source layer, that's where all of your Redis shards go. So the way that we scale out is by adding Redis shards. So with Redis Enterprise, this is a totally automated process that's completely opaque to the developer, right? You want to scale, you want to add shards, we'll automatically rebalance that for you, we'll automatically reshard it. All you got to do is say, I want to add a node, right? And then rebalance the cluster, which is huge. And then this is just another picture to kind of depict what I just talked about. A cluster of 3 nodes. We have a cluster management path and a data path. Our watchdogs are watching the ins and outs of a Redis Enterprise cluster, saying, hey, this node is being overwhelmed. This one goes down. I need to automatically fail over to this node. It's handling all of those bits and pieces that otherwise would have been a manual process. And when you're talking about supporting hundreds, maybe thousands of applications with Redis, you can imagine without something that's more automated, it's going to get really complex very quickly. And the second piece is that it's highly available, right? So we believe that when looking at mission-critical workloads, right, where downtime represents either massive business impact or potentially a company or mission-ending event. So like Treasury in a bank, missile targeting for the U.S. Air Force or the special operations. Black Friday for a major e-commerce retailer. High availability becomes a serious requirement and security requirement as well. So what we've done is taken the necessary steps to have things like active-active geo-replication, automatic failover, and a whole lot more, and I'll get into that in just a second. There we go. So our lessons learned in the past 5+ years in production, we manage over 500,000 databases globally. That's across 50 data centers. And we've supported over 2,000 node failure events with 0 data loss and 0 downtime. And that also includes over 100 complete data center outages. So we make sure your Redis is durable and it's highly available all the time. And the way that we do that, it's much more complex than just these 4 bullets, but because of the time limits today, I can't get into the specifics. If you have questions afterwards, please shoot me a note and we can give you guys the full architecture deep dive. But basically, to start off with, we replicate entirely in memory, so we're not persisting anything to disk. Failover happens 2 times faster. Replication is implemented by default across either your Redis nodes, across your Redis or your racks, across your regions, across your data centers, depending on your durability and availability requirements. I mentioned watchdogs a second ago. These are the guys who are internally to the cluster, making sure that everything is operating correctly, and if a node fails, it's automatically rerouting and replicating data from there. And lastly, I mentioned it a couple of times, but active-active replication, you can either run that in an active-active fashion or active-passive, dependent on what your topology looks like. This is just taking what I just said and putting it into a better picture. So obviously you can replicate across nodes, you can replicate across zones, across regions and clouds, and we make sure that your copies of your master data is never sitting on the same infrastructure so that if something goes down, your data is always going to be sitting elsewhere and will automatically be promoted to active and replicated from there. And the way that we handle active-active replication is really, really interesting. We use something called CRDTs, which stands for conflict-free resolution data types. This is a really groundbreaking way of looking at conflict resolution when replicating across data centers. Very complicated subject. Can't get into the specifics today, but something that I definitely encourage you guys to check out. So quickly, Redis is suited to fulfill a number of use cases today. Things like high-speed transactions for major financial companies, user profile stores for major retailers, real-time analytics, fast data ingest, and analytics from there for IoT. It can be used as a graph database for geospatial indexing, a message broker, etc. So just to put this into some real-life examples, these are a couple of the customers that we have to date. Virtually every vertical of every industry, powering their mission-critical and business-critical applications. Household names, Apple, Wells Fargo, Twitter, EA, etc. So before I jump into the Kubernetes and the container side of thing, I just want to give a real-life example of how we're helping a major credit card processing company out there. They're using Redis Enterprise as a caching, in a session store, replicating across 5 data centers globally. That's a combination of public and private cloud, and they're taking advantage of active-active with CRDTs. Consistent sub-1 millisecond latencies, global high availability. This is one of the applications that's powering their mobile e-payments, so you can imagine how business critical this is for that company. Okay, so I mentioned containers earlier, and I'm going to jump back into that now. Containers are a software development platform for users to develop applications inside of and run them, right? And that way the application can be abstracted from the environment in which it runs. This brings heavy operational efficiency on both the developers and the operators, right? Build it once, run it anywhere. A consistent environment, continuous deployment and testing, and that next level grade of security and isolation. So what I'm really excited about is what VMware and Pivotal are doing with PKS. So obviously, if you have a number of containers that you're deploying your applications or your data services into, you're going to need a container orchestration tool to be able to manage all of that, especially if you're running it in a microservices type of an architecture. And PKS allows you to do that in a very cloud-native way. It leverages the power of BOSH, which is a cloud orchestration tool, to really efficiently be able to run both your stateless services, applications, and your stateful services like your databases. So they bring a whole nother level of security, automated operations, production-ready HA to the Kubernetes scene. And I just want to quickly touch on what we're doing in the Kubernetes ecosystem, along with the work that we're doing to integrate with PKS. So over the past couple of months, Redis Labs has invested heavily into the integration with Kubernetes. About 6 months ago, we introduced the controller, which was our initial integration with Kubernetes. From there, we introduced Helm charts, and in the past couple of months, we've been working on an operator to fully integrate with Kubernetes, and soon to be PKS. It's still in the beta stages. The way that we're handling our integration with Kubernetes is really interesting. So we have kind of a double orchestrator type of approach. And the reason being, Kubernetes is great at orchestrating massive amounts of containers and workloads. What it's not super good at is the ins and outs of Redis, right? And even though you might think it can fail over and it can scale Redis, it's not dealing with Redis on the per shard, per instance basis. We already created an orchestrator for Redis, right? We have a cluster manager who does this. So we took this approach of having two types of orchestrators. Redis does what it does best. Kubernetes does what it does best. And what is that? It can be broken down into these 3 boxes, but there is a lot more. So from the Kubernetes side, it's dealing with the auto-healing of the nodes. It's also dealing with the scaling of the nodes, right? So with containers, we see a lot of ephemeral data is being stored in containers. So as you might scale out to 200 pods, and then you scale down to 200 pods. And we want to make sure there's no impact on the user experience. The way that we do that is by integrating Redis Enterprise into Kubernetes. So if we need to scale, Kubernetes will take care of that. Redis Enterprise is making sure that you're not losing any of your sensitive and critical data. So we're handling the failover, the scaling at the shard level, as well as the configuration and the monitoring. And lastly, together, that is like chocolate and peanut butter, right? In Kubernetes, you're not only going to run your Redis workloads, you're going to run your other data services, you're going to run everything involved in deploying your application. So Kubernetes is handling all of that, right? And PKS is bringing that next level of high availability security on top of that. We are making sure that if you are choosing Redis as possibly your primary operational data store, that none of that is going to go down, right? And we work very closely with VMware, with Pivotal, and with the greater Kubernetes ecosystem to make sure of that. So if you want to get started, I have some resources that you can go to. We did a webinar recently on Redis Enterprise with PKS. We did a technical blog on how to get started with Redis Enterprise on PKS. You can install Redis Enterprise. You can mess around with it. We have a free 30-day trial. You can also try Redis Cloud via any of your public cloud providers and test it there. You can reach out to me directly, Cassie at redislabs.com, or shoot me a note on LinkedIn, Cassie Zimmerman, or shoot a note to channel at redislabs.com, and that goes also to my solutions architect who works particularly on our platform integrations. We also have a presence here today. We have a booth over in the exhibitor hall. Feel free to stop by, have a conversation. We can answer any other questions. This was pretty high level, so I wasn't able to get too in-depth on the technology, but hopefully you guys kind of understood the overall architecture. So I guess now I'll open it up to the floor if you guys have any questions. to try to answer that for you. Otherwise, any questions? No? Yes? Say it one more time.
So container orchestration platforms like Microservices.
Yeah.
Do you guys compete with them, or it's
No. So the question was, do we compete with other orchestration platforms like Mesosphere? We do not. We actually work closely with those other partners of ours, including Mesosphere, where you would orchestrate, your other data services, but definitely not a competition. No. Complementary. Yeah. Yeah, that's a great question. So how many nodes are required for Redis Enterprise to be durable? The answer is 3 nodes. And I think I showed that in an earlier slide. But in order to have the replicated data across all 3, you can't have 2. That's the bare minimum for us, which is pretty common when it comes to at least NoSQL databases. Other questions? No? All right.